So as you can see, we have a lot of information here that we figured out early on before we even ordered the trailer. We started programming our requirements into a space, determined the size of the space, and then figured out what model we wanted and how we wanted it configured from the factory. And then from that, we built it out. But we knew exactly what we wanted in it before we worked out sizes and window locations, etc. So you can look at all this, and there's like electrical, and there's plumbing, and there's gas, and there's solar, and there's it's pretty overwhelming. Uh, I do that for a living. I do design work for resorts and high-end homes, and I do lighting design, and so I'm sort of in this world. So I don't want people to feel overwhelmed thinking they can just pull away from this and go do that. But this hopefully will give you some ideas and give you some guidelines as to how to go about it. And I guess the main thing is figure things out first before you start and plan it out as much as possible so that you're not making decisions on the fly unless you have to. Because typically when you have a fixed space, the decisions you make, you don't always have room to do what you need to do. So it's good to work it out ahead of time. Now you can look at what I'm doing here. It's like figuring out what material we're using, what the grade is of the material, how we're going to do the drawers, what hardware we're going to use for the drawers, what material is visible, what material is not visible, how are we putting it together, what are we going to finish it with, what kind of hinges, drawer slides, knobs, door catches, all that stuff. And if it's figured out ahead of time, you can usually buy it saving money because you're buying everything you need, plus you get it ahead of time so you're not waiting for lead time, and you get what you want, and you can budget it so that you know how much you're going to be spending, and you can pick the right thing for the job. So to start off with, when we ordered the trailer, we had to convey to the company that was providing it what we wanted. We had to give them the dimensions of where we wanted things, where we wanted the doors, where we wanted the windows, where we wanted framing, where we wanted vents. So you can see here there's a side elevation where we locate the windows, we locate the door, we locate the Salem vents. And so when they're in the shop framing out or laying out all this aluminum framing to manufacture the trailer, they're looking at the locations of what we've placed, and they're framing accordingly, right? And it's not just you get a trailer and you get the windows and you say, well, gee, let's build to that window. We actually determined what we wanted first, and then they put the windows where we wanted them. Really good way to go, and if you can manage it, it's a really good way to go. So they gave us, we configured the trailer so that we had a 6 inches higher, which is good for a living space. We have a wider RV style door, which is 3 feet wide, with a window in it. Two vents. Actually, we ended up with 2 max fan vents, so we had air coming in and air going out. And we have 4 Salem vents, 2 on each side, and those Salem vents are they're openable in tilting the vent toward the front or tilting it toward the back. So they're actually quite a flexible style of air device. Here's the other side, which is the left side, which is the street side. And we have a little shower door, trap door, which is the controls for our outdoor shower. And we have a framed opening for the hot water heater. And you can see that in the photo right here. they framed that in exactly where we needed it for the hot water heater, rather than us having to just shove it through there without proper framing around it, right? So worked out really well. You can see the Salem vents right there. And, top-notch workmanship. Super happy with everything they did. I even located where the spare would go, so we had room for the propane tanks. Located these Salem vents so that they worked out for our interior casework cabinets. So basically, you don't have to do it to this level, but I mean, if you put it on a piece of paper and you put down the dimensions you need and you send it to whoever's supplying your trailer, it'll serve the project well. This is a key plan which basically identifies the cabinets, the lower cabinets that are inside. So if you look at this, it goes water heater, cabinet 1, stove cabinet 2, sink cabinet, furnace cabinet, all the fridge. There's the bed support. These are the supports underneath the bed. So that number 13 is actually a water tank, and number 12 is an opening here, and then that's a drawer. So you'll see all that as I move along. Hopefully I won't take too long doing this because it's overwhelming. As you can see, we've got, like, how many pages here? 77 pages. So it's a lot of work. And we spent a whole year figuring this all out before we even ordered our trailer. So it was definitely an experiment, and once you see the end result, you'll see why we spent the time on it. So next drawing is an elevation. This is a rendering. Again, this is the kind of work I do, resort real estate, architectural stuff. So doing a rendering of this was something that was within my realm. So there's the street side of the trailer with all the call-outs to whatever features that it would include. Again, tandem axle, 3,500 pound Dexter Torflex axles, not leaf spring but Torflex, so they ride smoothly. There are the Salem vents. We actually even specified a thicker aluminum skin on the trailer, so rather typical trailers come with a .030, so that's 030 of a thousandths of an inch aluminum, and we ordered 0.4, which is actually significantly thicker. And you'll notice when you get that it doesn't have that wavy look to it, but it's actually quite straight and smooth. And it costs a little bit more, but in the long run, it's way worth it. Rear view camera, swing out security camera, aluminum rack with solar panels. So that's an 80-20 aluminum rack. So basically 80-20 is a system of aluminum extrusions that we mounted our solar panels on. So we didn't screw the solar panels directly to the top of the trailer. We screwed them to this rack system so they can slide off, and we have less holes through the roof. You'll see that too. I can get into details with different videos. Max Air roof fan. We thought about Fantastic fans, but we decided on Max Air roof fans because you can have them open and it can still rain and you won't get water in. You can leave your trailer with the fan open and you're not going to have a problem with rain. Aluminum Salem vent, access ladder. That's a concept that doesn't have to be there. It's just one of those things that we wanted, not really ordered with the trailer, but put it in the rendering anyhow. 36-inch RV door, wide, nice and wide, with a window, and a thing called a cam bar, which latches the door closed on top of the actual RV lock, which is a really good secure thing. We also added a latch on the outside, if you can see my mouse there, so that we can latch this cam bar open so people can't lock us into our trailer. Really important thing. Kind of crazy, but you know, important. Mesa siding is just another level of aluminum cladding which adds protection. 3x6 fluted aluminum center tongue member. The Legend trailers come with a huge center tongue that's 3 inches by 6 inches. It's this huge, big, massive thing that goes right underneath the trailer. You can see how far along it goes. And it's totally overkill, but you know, if you're going to get something like this, you might as well get it overkill because you want it strong and stiff. And boy, it sure looks substantial. 5,000 pound front jack. So these things come typically with like a 2,500 pound or 3,000 pound or whatever front jack. We got the heaviest jack we could get on the front of this thing because bigger is better. It's going to support it better. It's not going to fail. Levelers on the front and back. These aren't jacks to support the trailer. They're jacks which stabilize the trailer. The other thing that's a good thing with Legend are these aluminum steps. They have a fixed step here that's really solid and it's welded. It's not one of those things that rattle around. It's quite impressive, and you'll see photos of that as we go along as well. Let's see here. Outdoor power, exterior power, smooth fenders. Excuse me. Next page, there's a drawing from the front. There's that ladder again out of 80/20. Propane tank cover. There's the jack, siding. There's the wheel. Basically everything I talked about already. You can see a section of that 80/20 right here. So it's a hollow extruded aluminum that allows for T-slot fasteners, so you can fasten in brackets and cameras and solar panel fasteners and anything you want, really. And it's pretty good stuff. Not cheap, but it's really weatherproof and really strong. There's the street side view. Salem vent here, Salem vent here. That's our hot water heater tank. Not really a tank, it's an inline on-demand hot water heater. That's just the access door. There's our shore power outlet, and these are the city water and gravity water inlets and outlets. That's the shower door, access for an exterior shower. What else? Back, there's the rear. You can see the double hinges. So another thing we added was extra back hinges, because when you're opening these doors, if you want to hang anything on these doors, you want to make sure that they're strong enough so it doesn't hurt. There's a view from the top, so you can see the 80/20 extrusion front to back. And then we used cross pieces bridging the roof, so there's no holes in the roof. The holes are only along the edge of the trailer. And the edge of the trailer, if you look at the previous drawing, are right on this round. So their point load, the actual weight of everything on the roof, is actually right here. So it's on the wall rather than in the middle. So it's not, there's no sag here. And that's really important. If you're going to load up things onto the roof, you want to make sure two things. You want to make sure that your weight goes over top of the parts of the trailer that are going to support the weight. But the second thing is you don't want to have a bunch of holes in the middle of the roof, because if you get any leaks, they're going to be hard to get to. They're going to be hard to repair. They're going to be hard to get to and repair. So any of the fastenings that we have put on for this whole solar assembly have been brackets along the edge, and we actually tapped the bolts into the framing members, so that, and we used a thing called Manus Bond, which is a polymer that expands, and they use it in the trucking industry for the roofs of semi-trailers to make sure that they're watertight. And we also use butyl tape underneath those brackets. So you want to make sure that whatever you put into the roof is totally watertight, and it's going to be good for years and years. So that's that. There's the bottom, not much to see there. There's a layout of the upper cabinets, so you can see the countertop dash line, and then you can see over top you see a fridge, then you see an upper cabinet here, upper cabinet here, upper cabinet all through here. The back part of this is, we call it the garage, and right here would be all our electrical. Then we have a pass-through, and then we have shelving here, and you'll see what that looks like as I move along. There's a layout for flooring. So there's our Sureply underlayment. So it's basically an underlay over top of the factory floor in the trailer. It's really good if you're adhering any kind of flooring material. This is a good thing to put on there. We elected to use stainless screws rather than staples, and it's a nice flush joint. Stuff is fairly cheap and easy to work with. And then cork underlay, and then the 4-bow marmoleum, which is that linseed oil wood flower composite. Eco-friendly. If you go online and look up marmoleum, you'll see what it is. It's really good, clean stuff. If you go further along here, there's a layout of the countertops. So whoever's building the countertops needs to know what they're doing and what the thickness is and the depth and the width and the construction. So this is what we did here. We decided to do the main countertops out of Eastern maple, and then we decided to do a laminate every so many inches with a strip of Douglas fir. Right here you see fir and maple. Actually, we did the opposite, so you'll see that in our images. This dashed line right here you see going across, that's a removable countertop. You can see it right there. So basically you see a pantry here, you see a sink, stove, work surface. That's our waste cabinet. Over here you see a utility cabinet with a pedestal going up to the ceiling. And this is a temporary on-demand countertop when we need it. And it stores right there. You can see it stored beside the fridge. Now, this was just a rendering and a concept, but it actually came to be, and it worked out really well. And you'll see in future in some photos that we've got coming up. Okay, this is, you're going to blow your mind on this. Lighting. This is another thing I do for a living. Design lighting. And a lot of RVs, trailers, even really nice factory RVs, they come with lighting, but it's terrible. It's usually way too white on the spectrum. It's usually not dimmable. It's usually not programmed or focused on what you're doing. And so it's one of those things that people switch out and put better stuff in when they get their unit. So we elected to figure this out ahead of time. So basically what you've got are downlights, 2-inch downlights. You can see it right here. And they're reflector downlights. They're not just surface LEDs that blast light everywhere. They're actually they have a reflector in the back so that the light is actually focused into a certain location only and not splashing all over the place. They also have a thing called a gimbal, which is adjustability and direction. So you can see where I've located them, and you can see the radius of where the light goes. So if you look at each one, they have a surface area where they light up the countertop all along here, over the stove, over this workspace, over the temporary top, over this other top. And there's a couple of lights over the table, another one along that upper cabinet and another one in the garage. So what you're seeing here is an array of lighting that actually really nicely lights up the space. There's a ceiling beam going across here and another ceiling beam going across here. Each one has lights. So what happens is these are switched so that we can put these three on by themselves, or these two, these two, these two. So we can configure this and light it up however we want to light it, so that it's not all lit and so we don't have too much light or not enough light. The other thing you'll see here is a strip light that goes all along in here, which is a dimmable recessed strip light. The other thing we have is a night light, access light right here, which are red, and they are basically on all the time, and they just light up the doorway. So I'll just move along here, and these are the circuits for these lights. So I'm not going to go into great detail here, but if you look at circuit A, those are all on one circuit. B, that's another circuit. C, that's another circuit. D, there's another one. So these are all figured out for how many lights are on each circuit, how many watts, how many amps, which matters. Because when you're wiring this all, you want to make sure you have the right gauge of wire to be able to handle the power requirements for these luminaires. And somebody's got to do it. It's either going to be the person building it, or the electrical guy that's wiring it, or somebody's going to have to figure this out. If they don't figure it out, then you're going to have everything on one wire, and it's just going to light up or not light up, and that kind of wasn't what we wanted to do. We wanted to do something a lot more aesthetically comfortable than that. So we went way further along than a lot of people do. We did the wiring diagram for the wiring that goes from the distribution area in the back, where we have the electrical, to the switch panels. So you'll see later on in a video, this is a Blue Sea switch panel. It's fused, it's waterproof, and we have a couple of those on that pedestal which control the lighting for the overall space. And you'll notice also here that we have the gauge of wire shown. So if you look at this closely, you can see 12 gauge wire, 2-strand, Ancor duplex marine grade tinned wire, coated red and yellow, and red is positive and yellow is the ground. They elected in the marine industry to go to yellow for a ground instead of black, because for DC wire, because a lot of people were confusing the black wire in DC for the positive, when in fact the black wire in the DC realm is negative, and in the 110 volt realm it's the power wire, it's the hot wire. So they elected to go yellow in the DC realm for that safety concern. So we decided to use yellow for ground for that reason. This is probably a lot of information for some people, but for some people this stuff is important. So if you go to the next drawing, this is the drawing that leads from our panel 1 and panel 2 out to our lighting. So basically we've got everything all labeled A, B, C, D, E, F as the switches, and those switches lead to whatever lights we have. So in other words, for instance, circuit A, if you go along circuit A, it goes to those 3 lights that were on circuit A in the previous drawing. So if we go back to that circuit A, there's circuit A. Those 3 lights over the sink and stove, well, that's what these are, circuit A. And they go back to this switch right here, the top one, right? So it's all figured out. We've even figured out the gauge of wire, if you can see, it's 16.2 because it's carrying less amperage because these lights are only 1 or 2 watts, so they're not that big. I think we even use 12 gauge wire. So that's another thing you might consider is when you're wiring this stuff, always go bigger. Go bigger than rather than smaller in wire, because you never know when you're going to have to add things that you need to power up along that wire. So in other words, there's a table out there. Where is it? Yeah, here we go. 3% voltage drop. So basically, if you look at how long your wire is and how many current, what kind of current you need, you will get a gauge of wire that's listed in this table for the size of the wire that you need for that run. And that's for a 3% voltage drop at 12 volts. Well, for instance, if we need 5 amps and we have a 20-foot run, it tells us we need a 14 gauge wire. So if we look at that closely, 5 amps, 20-foot run, 14 gauge wire, right? So what I would do is I would make that a 12 gauge wire, because for 2 reasons. One, you never know when you're going to have to add things to that wire end. In other words, add a couple of lights or add some 12 volt outlet or something. The other thing is when you have just the required amount of size of wire, there's a potential for that wire to get hot. And if the bigger the wire you have, the easier it is to handle heat. So it's a good idea to oversize your wire in all cases. It's not required, but it's a good idea. Okay, let's go back here. What do we have? We have, there's where we left off with our switches to the lights. Okay, these are our distribution box, distribution panel. There were 2 distribution panels in the trailer and 2 distribution panels in the garage, and they power appliances and USB outlets and various things. For instance, we have a 12 volt solar fridge, which is powered by this distribution panel in the back. A Propex heater, which is a 12 volt propane heater. We have quite a few of the Blue Sea USB charging outlets, voltmeters, water heater. So it's a propane water heater, but it does have electrical, and the electrical is 12 volt. So any 12 volts you need to figure out. And figure out what kind of wire you need. You'll notice the water heater has a heavier gauge than some lighting, right? You'll notice the fridge has a heavier gauge than lighting because it requires more amperage, right? So that's important. That's important stuff. And it needs to be figured out. There's a close-up view of the Blue Sea panel. And fuses are always good rather than breakers in my books for 12 volt. And here's the layout of circuit A. Remember that? Lights, galley sink. There it is. 2 amps, circuit A. And here's everything. These are at the entry. Panel 1 and 2 are at the entry. Panel 3 or 4 are in the garage. So remember I was saying these are all lights, right? And then back here, these are all appliances. So all figured out, including the wiring diagram behind here so that you know how to wire it and what to wire, where the bus bars are, where the positive is, where your connections go. So next thing in line is the 110 system, which is the shore power, which is household voltage. And there are some things on our trailer that are household voltage, AC, alternating current. Things like the microwave, the TV, stove ignition, um, and then outdoor outlets, and then indoor outlets. So we elected to use the ground fault current interrupt outlets, GFCI, which is the outlets you use in the bathrooms in your household. But we also went a step above that, and we use the arc fault option as well. So they're called a GFCI AF spec, and it's a thing in Canada where arc fault basically interrupts current if there's a spark, not just a problem with the ground or a short, but if there's a spark. And it's much safer. They're what, $5 more than the ground fault outlets, but I think from what I know in RVs, you need one of those on your 110 circuit in an RV in Canada, in new RVs. So we decided to put them in. Again, there's a wiring schematic on the back of the 110. Pretty straightforward. Let's see here. There's your 110 diagram from your inverter. There's your shore power. And then these are all your currents going to the different appliances, right? So you got your outdoor outlet. You have a microwave. We have ground fault outlet near the pantry. We have a stove convection fan. We have a ground fault outlet. We have a TV outlet. We have a garage outlet. We have dining rail and dining rail outlet. And we also use this 110 to power Starlink. Starlink is powered by a 110. The router is powered by 110. So you, again, oversize your wire. You never know what you're going to need to hook up. And it's really a huge pain if you have to run heavier wire through your raceways. We overlaid a whole bunch of systems. We overlaid plumbing and propane. So here's your plumbing. And if you look at it, you can see freshwater tank. You can see gray water tank. So the freshwater tank is here, the purple dashed line. Gray water tank is here, the purple dashed line. We've got gravity water fill, city water fill with a back check valve. That's what those things are. Those little things with a dash line in them. And this is my dog sleeping in the background. Okay, what do we have here? There's a water pump. There's a accumulator pump. There's a gauge which tells us what the pressure is in our water system at any time. We have a sink and a faucet and a drain at the bottom of our gray water tank. So this is pretty straightforward, right? It's all along one side of the unit, and it's all color-coded. Blue for blue PEX, and which is this stuff, right? And red for hot. So cold for blue, red for hot, and there's your bypass for your hot water tank right there. So again, this drawing gives you a basic understanding of how we laid out our plumbing. There's the propane layout. So basically you've got 2 propane tanks and propane line going to our furnace, going to our range, and going to our hot water heater, with a ball valve underneath the trailer. You're not allowed to have a joint inside the trailer, but you can have these outside the trailer underneath. So we've got a ball valve underneath each one of these appliances. And one interesting thing, we used copper line, all sized according to what the BTUs are required, but we decided we wanted sleeved copper for protection, because copper is soft. It doesn't puncture easily, but it crushes easily, and it's vulnerable, right? Excuse me. So if you look closely at this, you can buy sleeved copper, but it comes in huge rolls and it's really expensive. So we decided we would sleeve the copper ourselves. So we got a gas fitter friend to run the copper, and before we made all the joints, we used nitrile rubber sleeve hose and pulled it over top of the copper for protection. And you'll see in a couple of the photos what that looks like. And it's, as far as I'm concerned, the way to go. It's the best way to do gas line underneath a trailer. You just got to make sure it's tucked up underneath so it's not exposed down below, and you're good to go, really. So there's that. There's the roof with the 80-20 extrusions, and you can see the longitudinal extrusions right there. And then cross members, ultralight. There's 3 different levels of this 80-20 stuff. There's different sizes, but there's also different weights. There's a normal one, there's a light one, and there's an ultralight. And you want to make sure you don't put the heavy stuff on the roof, because it's it holds a lot of weight. So you don't need to use the full thickness 80-20, because it's totally overkill and it's too much weight for what you need. So just use the light or the ultralight, and it'll more than easily handle solar panels and anything you want to put on there. So you can see our solar panels, you can see where the max fans are. It didn't work out exactly like this. We used a different layout, and we used a J box here, a big like a scepter junction box, and you'll see that as well. We used Renogy 100-watt panels though, and we like them. They're pretty happy. We're pretty happy with them. There's a view of the back garage. You can see the electrical layout right there. So I'll go into that shortly. For now, just have a quick look at what that is, and we'll continue this on in a few minutes.